Okay, so I'm telling you, and the book is telling you that things are heating up, but you're a smart kid and you are skeptical, and it is a good thing to be skeptical. Skeptical means you ask questions. Why, how, when, where, and so on. So if I say things are heating up, you must say, how do you know? Why should I believe you? Right? So obviously, scientists have taken measurements from weather stations around the world. It means it's an instrument that sits there. It can measure winds, it can measure temperatures, it can measure radiation coming from the sun, it can also measure thermal energy going out from the surfaces, and it can measure the energy moving around. And here is a nice scientist who has put his instrument somewhere and he's going and looking at the data and taking measurements, and these are called weather stations. And there are satellites doing that, there are robots doing this, even the airplanes flying around are measuring things. Everybody is measuring things for tracking the weather. And when you have a lot of data over many years, we can make averages and find the climate as well, right? So scientists have taken measurements from weather stations around the world, in hot places and cold ones as well, and the average temperatures in all these places have gone up almost 2 degrees Fahrenheit since the 1880s. I added the last two podcasts basically to avoid simplifying things too much. This says average temperatures in all these places have gone up almost 2 degrees Fahrenheit since 1880s. Well, not quite. There are some places which have warmed more than 2 degrees, like the Arctic, there are, and the Middle East, and there are places which have warmed much less than 2 degrees Fahrenheit, or have even cooled since the 1980s a little bit, like north parts of some parts of India and so on. So when you average everything over all the world and all the stations are averaged, then you get that things have warmed up over 2 degrees Fahrenheit. So just remember that. So this may not sound like a big difference, 2 degrees Fahrenheit. You know, when you go from winter to summer or winter to spring, the warming is maybe 10 or 20 degrees Fahrenheit. So why are we worrying about 2 degrees Fahrenheit change over such a long time, right? That's a fair question, and you should ask such questions. Earth has been having fewer cold days and more warm days. There have been fewer record low temperatures and more record high temperatures. Now we are talking about anomalies from the baseline. So if we take the average from the 1880s to, let's say, 2023, and look at every month, let's say, and then we measure each year's month, January, from the average January over the years and so on, we are seeing that the number of cold days is decreasing and the number of warm days is increasing. There have been fewer record lows, which means people were used to having cold winters, but really, really cold winters in some years, and you would get record low, which means over all the years for which you have data, you have never seen such a cold temperature, or a record warm year, where warm a month where you have never seen such a warm temperature before in a particular month, especially if December is supposed to be very cold in where you are and it's very warm, then you will have a very high record warming there. So even freezing cold places are getting warmer, and not just in the Arctic. It's also happening in Antarctica. You know where the Arctic is, the North Pole, and Antarctica is at the South Pole. Ice caps, glaciers, and ice sheets, all forms of land ice, are melting. Remember, we already explained the glaciers, and we'll look at it again. And ice caps are just, they are on top of a peak, like on a mountain and on the pole and so on. And ice sheets are when they get large. But glaciers are different from sea ice because they are forming on land, and they are forming by compressing snow. Snow falls this year, this winter, fall and winter, and it's cold, so it doesn't melt during the summer. Then more snow falls on top in the next fall and winter, and the weight begins to compress the snow and it becomes like ice. It's glacier, but it will see that it flows like honey or molasses. Okay, so they are beginning to melt. All forms of land ice are melting. Sea ice also is decreasing. Remember, sea ice is formed by freezing the ocean water. When the atmosphere blows winds and atmosphere is cold, it is taking away the heat from water. Remember, if water is sitting there as liquid, then it's not frozen, which means its temperature is probably 0 degrees or above. But there is a trick. If it is a lake, of course it is 0 degrees or above if it's not frozen. But in the ocean, what happens? There is salt in the water, and when you add salt to the water, what happens to the freezing temperature? If you live in high latitudes like US, Canada, Europe, maybe you have seen that when the weather forecaster says there is snow coming, a truck may be going around spraying salt on the walkways, on the roads, and so on. Or your parents may be going out and spraying salt on your part of the walkway leading up to the road, and so on. Why do they do that? When you add salt to the water, it freezes at colder temperatures, so that when it gets colder and colder and colder, it doesn't start freezing at 0 degrees, but adding salt lowers that freezing temperatures, which means if the ocean is in liquid form, it doesn't mean it's 0 degrees or above. It can be less than 0 degrees because it has salt in it. But nonetheless, when it freezes, it forms ice, unlike glacier. And the other thing to remember, the little details matter, kids. When ocean water freezes, it removes all the salts. It only keeps mostly water. Very little bit of salt will be left. So it's called brine, B-R-I-N-E, rejection, which means salt is rejecting the salt and keeping just the water molecule, and so on. And sea ice floats. Why? Because you have probably learned that the density of water decreases as you cool the temperatures, but at some point it begins to increase again, because the way the water molecules are arranged together becomes more voluminous as you decrease the temperature. So the maximum density is not at 0 degrees for fresh water, it's somewhere around 4 degrees. You can check it out. So sea ice floats because its density is lower than the unfrozen water. And it's a good thing, because when the glaciers fall off the land ice from the mountains of Greenland and Antarctica, and when sea ice forms, it's floating on top and the ship can see it. Remember the Titanic? Maybe you haven't seen the movie, but you can ask your parents or your older brother and sister about it. The big glacier that broke off and came in the ocean, and the ship didn't see it quickly enough, and it was moving too fast and went and crashed into the glacier. And glacier is very heavy, and only 10% remains above the water. 90% of that big glacier is under the water, and it cut the ship and completely sank the ship, and a lot of people died. So ice floats, glacier floats, and that's what you have to remember. Okay, so this is how we know, and here are some pictures. This is the Plateau Glacier circa 1961. You can see the glacier is flowing like molasses because there is a slope. So snow falls on higher altitudes, and it begins to fall and fall and fall and compressed and becomes glacier, and then it begins to flow like honey and keeps coming down the slope towards the ocean and carves the rocks and so on, because frozen water can split open the rocks and break it into pieces, pushes some rocks ahead of it, and so on, and keeps flowing. And if you look at the same Plateau Glacier in 2003, you can see the glacier is gone. This is all glacier flowing here, and 2003, boom, it's gone. Bad news, right? This can only happen if you're warming. And there are some feedbacks that happen as you begin to melt the glacier that we'll talk about a little bit later. So there is evidence all over the place that places are warming. So let's leave this podcast here about how Grandpa knows that things are heating up. Who's Grandpa? I'm calling myself Grandpa here just to make you focus on learning and asking questions. Because if you think of me as the teacher, you may get scared of asking questions, but think of me as Grandpa and feel free to ask questions. You can call me Uncle as well, but now I'm old enough to be Grandpa and I have many grandchildren. Okay? See you in the next podcast.